It's estimated that by the year 2050, half of the world's agricultural land will be affected by some sort of salinity problems. Now that is massive, and that's exactly what we'll be talking about today. We'll be talking about soil salinity, the problems with that, why that's the problem, and what we can do to fix that. My name is Still Simmons. I work with growers to restore their soils using principles that we'll be talking about here today, which is embedded within Regen Ag. If you like what I'm saying here today, make sure to firstly subscribe, and secondly, reach out to us. We work with growers across Australia in improving their soils. So simply, soil salinity is the concentration of salt within the soil water. So it's not just salt in the soil, as some of that can be, some of the salts or cations and anions can be bound to the soil particles. This is the amount of salt in the soil water, so the actual water in our soil. And so the salts include most of our cations and anions, so any of the elements with a charge, but more specifically, these are the main four that impact salinity the most. So that's sodium, chloride, potassium, and sulfates. And we can measure the salinity of our soils by measuring the EC, which stands for the electrical conductivity of our soils. And that's simply the ability for a current to move through our soils. And that's usually based off the amount of cations and anions in our soil. And so when you think of a current, it's the moving electron going through, bouncing between our ions. And so when we measure our salinity, usually you might be able to get this on a soil test, or if you measure it yourself. Now, most of the time on your soil test, you'll get a EC value in DS per meter, and that's what all of these are in. And so basically, if we get a value between 0 and 2, that's pretty good. And your soils are classified as non-saline. And then it works down from there. So if you get a rating of 2 to 4, that's slightly, and then we get slight, moderate, and very. So really anything below a 4 is pretty, that's going to be affecting the yields on your crop. Some crops are able to perform better in saline soils, and others less so. So like barley, that's pretty tolerant to salinity. Other things, not so much. And so when looking at what we're going to plant and looking at the ways we're going to manage salinity in the future, crop selection is very important. And so there's a few reasons why salinity is such a problem with our plants. And firstly, we'll talk about osmotic pressures and the ability for our plants to take up water. So the biggest problem with salinity and a high salinity is that it prevents our plants from absorbing water and uptaking water. So it's almost like if you were to drink seawater, you're not going to get hydrated from that. And so the reason for this is a concept called osmosis. And the way this works is that, say we have two tanks, or we have water in a dish, and that's separated by a permeable membrane, which means water can pass between these two bodies of water. This body of water has lots of salt in it, so it's very salty, and this doesn't. So say we got 1 bit of salt to 100 bits of salt. What the water will want to do is equalize the concentration in salt between these two bodies of water. And so what will happen is that the water from here will pass through that membrane into this side. So the water will actually flow into that, therefore increasing the amount of water volume and then decreasing the amount of salt, the salt concentration, while increasing the salt concentration here. This is the exact same thing that happens with plants. It's a little bit more complicated, but essentially we have a higher concentration in our plant and lower in our soil. So water will flow from our soil into our roots and then up the plant. Now let's just say this is a healthy soil. It doesn't have too much salt in it. The difference between these 2 points, or say it's going to be a 1 to 100. Let's just say we increase the salt in this to 10. The difference between this is going to be a 1 to 10. So basically a 10-fold reduction in the pressure between that point. So the water between here is going to be moving at a slower rate than otherwise. And so this is the exact same thing that happens when we have a really high concentration of salt in our soil. It prevents or reduces the, force pushing up into our plants, and therefore it's going to be reducing the amount of water that the plant can pick up. And so that's one of the biggest factors, is that it reduces our water uptake, and that's pretty important when we're talking about really dry areas such as Australia. If we have saline soils and we also don't have much water, that's going to be pretty problematic. There's a few other things that a saline soil will prevent or reduce the nutrient uptake. The main ions in our soils that contribute the most to salinity is sodium and chloride. And so when we have a lot of those ions, it can inhibit the uptake of other minerals. So for example, calcium, potassium, magnesium, and ammonium, they're all going to be inhibited by a large amount of sodium, just because of those minerals are competing for entrance into the plant. And the same thing for chloride and our nitrates and sulfates. They're all going to be competing with each other. And lastly, it's going to inhibit microbial activity. Microbes are very sensitive to the salt in our soils, and so when we have really salty soil, the microbes aren't going to like it, aren't going to be functioning the best they could be. So overall, it just makes things really hard to survive in that soil. They're not going to be functioning the best they can. They're not going to be able to access all the water and nutrients in our soil. So how does the salt actually get into our soil, and how can we get rid of it? So think of this as our soil. We have our plants growing at the top, the roots, we've got the top of our soil, we have soil profile, and then we also have the water table. So that's the natural point at which the water rises into our soil profile. And so firstly, how can salt get into our soil? So the first is rainwater. There's a little bit of salt in our rainwater, not enough for it to be bad as it is, but over thousands and thousands of years, with all that rain, the little bits of salt adds up over time. And in Australia, where our evapotranspiration is much greater than our rainfall, that salt starts to build up. And over thousands of years, that salt really builds up until we have problems. And so that's the first way salt can get into our soils. The other one is that the mineral makeup of our soil is just naturally salty. There's not much you can do about that. If the rocks that your soil is coming from has a high amount of these ions, it's in the makeup of our soil. There's not much you can do about that. Now, the way salt naturally leaves our soil is through drainage and leaching of those salts. So say this is our soil, we have salt all through that. When we get rain, when we have rain coming down, that will dissolve these bits of salt, and they will go into our groundwater. What will happen is that this groundwater will naturally move to waterways, so it will recharge waterways, and then that will be moved out to the sea. Now, this process takes a long time for salt to actually move out of our soil profile and into the river and out to the sea, but that's the natural system of salt coming in and being almost flushed out of our soil profile. Now, that's all a natural system. What we kind of have done with agriculture is disturbed that system, added more salt, and prevented the leaching away of those salts. And so one of the ways is rising the water table. Two ways this can be done: over irrigation. So we irrigate so much that the water table rises up, bringing all those dissolved salts with it. And so as it rises, it dissolves the salts and brings them to the surface. The other way is that we've cut down a lot of the trees and removed a lot of perennial pastures, and that has also caused the water table to rise, bring up those salts too. And so that's typically called dryland salinity. And the other one, which is irrigated salinity. And irrigated salinity usually occurs when we're using irrigation water that is saline already. So we're taking it out of waterways that have been collecting all the salt, and then we're reapplying it. So we're applying salty water to our paddocks, and no wonder we have a saline problem. So that's how a water table can rise, and that will be preventing the leaching away of salts. Another thing that we've done is we keep adding salt based fertilizers to our field. So for example, one of the most popular fertilizers for potassium is potassium chloride, which are our two main salts that contribute to salinity. And so when we're applying a heap of this, they'll go into our soil and naturally increase the salinity of our soil. So adding a lot of salt-based fertilizers will increase the salinity of our soil. That, with not having a well-cycling system, has allowed for salt to accumulate in our soil and it's not getting flushed out. So what can we do to alleviate salinity or to get rid of all that salt? So the first one we can do is to improve our soil structure. That's going to allow for more water to flow through our soil and allow that soil to be flushed out. Now that leads us on to our second one, which is actually flushing out that salt. If we're lucky enough to have lots of irrigation water available, what we can do is firstly test that irrigation water. We don't want to make sure we have heaps of salt in it. We're just adding to the problem. But if we irrigate and try and flush that salt out, that could work, but it's probably pretty expensive and might be better ways to get rid of that salt. The other one is reducing salt-based fertilizers, so using carbon-based amendments, which is usually better. So when we can reduce our salt-based fertilizer, we're just reducing the amount of input of salt that we're putting onto our field, which will alleviate the problem. Another way we can reduce our salinity is by planting more trees. That's going to pump out more water out of our groundwater, which is going to prevent that from rising. And the other one is cover crops or perennial pastures. They're going to improve our soil structure and also do the same, pumping out more water out of our groundwater. Now, it's important to know what is the actual cause of salinity for your farm if you're having a problem with it. Is it a rising water table? Is it that you're adding too much salt-based fertilizers? Is it that you cut down on the trees and you're not pumping water out? What is the actual problem? You can't really fix the problem until you realize what the problem actually is. And so coming to the actual source of the problem and then fixing that is the best way to do things. Now, it is important to note, salinity is not sodicity, which is the concentration of sodium. We'll have another video on that, which you'll be able to find on the YouTube channel, talking about sodicity and all the problems that come from that. But salinity, which is salt, so salinity and salt, this is all the problems that we get from that. And think of it just as you're drinking seawater and all the problems that would arise. Cool, well that's it. Thank you very much for watching. Again, make sure to share this with someone that might be having a problem with salinity. It's a pretty tough problem because you can't fix it with applying stuff. You can't fix it with chemical amendments. You just have to change your the way we manage our farms so that we're able to remove more salt out of our profile and reduce the salt that we're putting in. Awesome. If you're interested in implementing any of these things onto your farm, make sure to reach out to us. You can go to our website, which will be in the links below, and just reach out. Awesome. Thanks for watching. Cheers.